a point is moving on the graph of x times y equal to 42. So you have a graph of this implicit equation, let's say x times y equal to 42, and a point on that graph is actually, let's say, moving on the graph. Okay, so let's assume in that way. And the question is, when the point is at this point, let's say 7 comma 6, it says that the x coordinate is actually increasing by this rate, 7 units per second. Okay, oh, it's not even a question, it's just given, right? When the point is at that point is that location, its x coordinate is increasing by 7 units per second. The question begins here: how fast, okay, is the y coordinate changing at that moment? So if you do not get this question, first of all, like, spend good amount of time to understand the problem. Okay, now if you understand the problem, let's try to extract the information. What do we have here? So you know that these are related rate problems where generally we will have a relationship between the variables, right? And we need to actually, using that relationship between the variables, we need to come up with the relationship between the rate of change. That's the main idea here. So let's have that in your mind, and then let's try to go back and again revisit the question. So a point is moving on the graph of x times y is equal to 42. You can clearly see that that means now we have a relationship between x and y, which is actually now equal to given as 42, right? And what else we have given? It says that when the point is at 7 comma 6, x coordinate is increasing. What does it mean by increase? X coordinate is increasing by 7 units. That means the rate of change of x, right? So the rate of change of x with respect to t is actually given by 7. But it's not always like that. It just say this is actually true only when the point is at the moving point is at this location, 7 comma 6. Okay, so that is also given. The question here is how fast. That means you need to figure out the rate of change of the y coordinate at that moment. So in that case, the question is find out what is the rate of change of y with respect to t, right? When the moving point is exactly at that moment. That means when it is at 7 comma 6. So this is the question. Alright, so x and y are the two variables on whole this problem, where we have a relationship between x and y which is given. We have also given the rate of change of the x variable with respect to t at certain time, right? At certain, let's say, a moment where the point is at 7 comma 6, the moving point, its rate of change is 7. Our goal is to see what is the rate of change of y with respect to t. So this is what the question is. So once you extract all of these information, we can actually just focus on these equations. So let's try to spend time on here. All right, so we have x times y is equal to 42. This is a relationship between the variables. So how do we find now the relationship between the rate of change? We need to differentiate with respect to t, because the point is moving, so x and y, it is depending on the time, right? So that's why let's try to differentiate both sides with respect to t. So let's differentiate x times y with respect to t. Let's differentiate 42 with respect to t. I believe to differentiate these the 42 with respect to t is not a problem, because that is just a constant. So derivative of the constant is 0. So done on the right hand side. Now let's focus on here on the left hand side, where we have actually product of two functions x and y, right? Something like that. So we need to use the product rule. So how the product rule work? Leave the first function as it is, multiply by the derivative of the second. So derivative of y with respect to t, plus find the derivative of the first term with respect to t, leave the second function as it is. So you can see here we had originally given a relationship between x and y. When we differentiate with respect to t, we get a relationship between the rate of change, and you can clearly see there is actually the rate of change are related with each other. So that's why we call related rate problem, right? Okay, so we have the related the relationship between the rate of change. So if that is the case, our goal is to find out what is the derivative of y with respect to t. So if that is the case, let's try to plug back all of the information in. So we need to figure out the rate of change of y with respect to t when x equal to 7, y equal to 6, right? So if that is the case, plug those in. So let's replace x by 7. Okay, so x is equal to 7 times, we don't know what is derivative of y with respect to t, that's what we need to figure out, so leave it like that, plus derivative of x with respect to t, that means rate of change of the x coordinate with respect to time. We have given that, right, which is over here 7. So let's plug that in too, right? So that's also given, let's plug that in. And what is the one other thing we need to write down is y. What is y? The y coordinate is given over here, right? So we need to figure out when y equal to 6, then we need to figure out the rate of change. So let's write that down. So this is equal to 0. All right, so you can see here it's actually now we have only relationship between we had only relationship between the rate of change. We try to plug back the information in. When we do that, only derivative of y with respect to t is unknown. So if that is the case, we can immediately solve this, right? So this can be simplified as 7 times derivative of y with respect to t plus 7 times 6 is 42 is equal to 0. Then how do we solve? To solve dy for dy over dt, derivative of y with respect to t, what do you do? We need to subtract 42 on the both sides. So let's do that. So when we do that, this will be in negative equal to negative 42, right? And to isolate derivative of y with respect to t, we can divide by 7 on the both sides. So this will be equal to negative 42 over 7. So what do we get here? Negative 6 as an answer. Wow, okay, we get the required answer, right? So the rate of change of the y with respect to t is negative 6, no problem with that. But what does that mean? How fast the y coordinate is changing? Well, if derivative of y with respect to t is equal to negative 6, then what we can say is the y coordinate is decreasing, right? Because we have the negative rate of change there. So decreasing at what rate? At 6 units per second. Why didn't I write down negative 6? Well, the negative will, and the negative sign will only, or positive sign will only tell you either it is increasing or decreasing. So the question was how fast, right? So we need to just write down the neglecting the sign, whatever number we have, we need to just write down, right? So fast means speed. So speed can be computed by finding the absolute value of the velocity, right? So that's how, I mean, just take the absolute value of the rate of change, so that will give you the answer. And to about the negative or positive sign, for that we can write down either it is increasing or decreasing.